Okay, the factor theorem says that if the remainder is 0 when a function is divided by a linear expression, then that linear expression is a factor of my function. Okay, so we've looked at the remainder theorem, which says if I divide this function by this linear expression, then I make this 0 and I solve for x, and that value I substitute into the function. That's the remainder theorem, and that gives me the remainder. Now, if I do this process and I get a remainder of 0, then this is basically a factor of that. Right. So this is a spin-off of the remainder theorem, which basically says if the remainder is 0, using the remainder theorem, then that bracket that I started with will be a factor, one of the factors. When I factorize this function, this will be one of them. Right, so with the remainder theorem, what I did was I said x plus 2 is 0, then I find this value -2 from that. So now the factor theorem says basically, if I substitute this -2 into my function and I get 0, then this bracket is a factor of that function. Right, so let's substitute this into the function. I have x cubed plus x squared minus 13x minus 22. And if I substitute -2 in there, you can actually just use your calculator. So I have x cubed plus x squared minus 13x minus 22, and the x value currently is -2. Okay, then I get 0. Okay, so this gives me 0, and then that means that x minus -2 or x plus 2, x minus -2 or x plus 2. If you substitute the value in and you get 0, then x minus this value, which is x plus 2, is a factor. This is basically the result of the factor theorem. All right, so now let's look at a bit more challenging question. They say two factors of this function, where there's a and b unknown, are x minus 1 and x plus 2. Find the values of a and b. Right, now if x minus 1 is a factor, then that means if I solve x minus 1 for 0, and I get x is then from this 1, and I substitute that 1 into my function, I should get 0. So I have a value x is 1 from this, and if I substitute f into my function, x1 into my function, then I should get 0. And also if I substitute x equals to -2 from this bracket, if I substitute -2 into my function, I should get the remainder 0. Right, so let's do this. The function is x cubed minus 2x squared minus ax plus b. And for this side also, x cubed minus 2x squared minus ax plus b. And then here I'm going to substitute 1, and here I'm going to substitute -2 into my function. Right, so this, I have 1 cubed is just 1, 1 squared is also just 1, so this is just -2. A times 1 plus b. Oh, I forgot to put the equals to 0. Okay, then this means that 1 minus 2 is -1. I'm going to take that over to the other side so that it's +1. And I'm going to take this -a to the other side also so that it's 1 plus a. And then the b is on this side. So I have an equation in terms of a plus b on this side. Let's look at this one. I have -8. -2 squared is +4 times -2 is -8 also. Negative times negative is +2a. plus b equals to 0. And from this I have that 2a plus b equals, if I take this negative 16 over, I have 16. And then I basically have two equations that I have to solve simultaneously. Now I have a specific method I use for simultaneous equations, but you might have another one. If you know another method and you're comfortable with the other method, that's absolutely fine. You can just pause the video and do your method and then check back to see if you get the same answer as me. So what I do is I start getting the a or the b alone on this side. Now the b is already alone, so then I substitute that into this equation. B is 1 plus a, so this b in this equation must be 1 plus a, right? And then I simplify this a little bit. 2a plus 1 plus a equals 16, so 3a equals 15, so a equals 5. And then when I get a value here, I'm just going to substitute that back into this equation. So b equals 1 plus a, and a is now 5, which means b is 6 and a is 5. Right, so there I have the values of a and b.